Hi everyone. I am going to be talking to you guys today about naming polynomials and end behavior and how these two things are related. You guys have been dealing with polynomials for a little bit now. So a term is a combination of a number and a variable, and a polynomial is a combination of terms separated by addition and subtraction. And we're going to talk about in a moment that these polynomials have certain names given certain criteria. One of the ways that we name a polynomial is by the number of terms. So how many terms are there that are separated by pluses and minuses? So this one only has 4 different options. If there is only one term, we call it a monomial. If there are 2 terms, we call it a binomial. 3 terms is trinomial. And then after that, we get a little bit lazy and we just say polynomial with a certain amount of terms. So if there's 6 terms, we say a polynomial with 6 terms. Another way we name a polynomial is with their degree. So the degree of a polynomial is the largest whole number exponent of the variable. We use this to determine how many solutions we would find utilizing the fundamental theorem of algebra. Now we're going to use it to be able to name our polynomials. So a polynomial is written in standard form when the terms are written according to its degrees and then in descending order. The most common standard form you guys have worked with has been the quadratic standard form, where you guys had ax squared plus bx plus c. As you can see, the x squared is first, and then the x, and then the number. Standard form of a polynomial is just the largest degree, whatever that may be, to the smallest degree. So the other way that we name polynomials is by its degree, and its degree is based off of the largest exponent in the polynomial, which is typically the first term if it is written in standard form. So if the degree is 0, meaning it's x to the 0, which means we typically don't see the variable, we call it a constant. So this would just be a singular number. If the exponent is 1, meaning x to the first, we call it a linear. And then this one you guys are the most familiar with, x squared, or something with a degree of 2, is called a quadratic. And then we continue with degree of 3 is cubic. The degree of 4 is quartic. I like to think of this as like quarters. 5 is quintic. And then again, after 5, we kind of get a little bit lazy. So if your highest exponent is 7, you would just say 7th degree. We do expect you to tell us that if you have an x to the 5th term, that it is quintic, not that it is 5th degree. So please make note of that. We will not take 5th degree. We will take quintic. We will not take 4th degree. We will take quartic. So the leading term of a polynomial is the term with the highest degree, which means that if your polynomial is not written in standard form and you rewrite it in standard form, it would be the first term. The leading coefficient is the number that is associated with the leading term. We're going to talk about importance of the leading coefficient when it comes to end behavior. For now, the leading coefficient does not play into naming the polynomial. The leading coefficient is more important when it comes to talking about end behavior, which I will talk about in a moment. So, to wrap up how to name polynomials, what I like to think about it is the degree is the first name and the number of terms is the last name. So we always say degree first and then number of terms second. So again, degree is kind of like a first name and number of terms is kind of like a last name. We never say monomial constant. We would say constant monomial. So let's do a few examples. Again, rewriting this in standard form will potentially help you name it, because if you look right away, a lot of students will make the mistake of trying to name it by this term, this 5n cubed, but that would not be the appropriate name for this polynomial. If we were to write it in standard form and take a second and do that. So in standard form, this would be 8n to the 7th plus 5n cubed minus 6n. So everything is based off of this guy right here when it comes to the degree. So the degree is 7. So again, we're in this territory of nth degree. So we would say 7th degree. And again, this is the first name. And then we're looking at number of terms. So we have 1, 2, 3 terms. 3 terms would be trinomial. So this would be a 7th degree trinomial. Let's do another one. Again, take a second, rewrite this in standard form so you know what the leading term is. So standard form of this would be 8m to the 4th plus 4m cubed minus m squared plus 1. Again, this would be the leading term. The degree of that is 4, so we would call that a quartic. Again, first name. And then number of terms is its last name. So we have 4 terms. And again, anything after 3, we say polynomial with. So this will be polynomial with 4 terms. So this official name is quartic polynomial with 4 terms. So understanding standard form, understanding the leading term, understanding number of terms helps you name these polynomials. Now we're going to talk about the end behavior, and the leading term is actually solely what we're going to use in order to determine the end behavior. But we're going to talk about it from a graph perspective first. So end behavior of a function describes what the function is doing all the way to the left as x gets smaller, more negative, and all the way to the right as x gets larger or more positive. The most common way that we see this represented in math, and we're going to do it this way in Algebra 2, you will see this again in Precalculus, and it will become very, very important in calculus regardless of whatever level you take. We use what we call limit notation. You can think of this as almost like a speed limit. It is the speed that is suggested that you stay around, that you approach as you're driving your car. Now we know that speed limits aren't always followed, but you can kind of think of a limit as something like that. What are we trying to approach? What speed are we trying to approach? What values are we trying to approach? There's different values on this graph. So what values are we approaching? Well, it's talking about approaching y values. So as we go to the right, which is the blue, right is a positive infinity idea. We want to think about, is my graph going up or is my graph going down? So if my graph is going up, this would be equal to positive infinity. And if my graph is going down, we're going to equal negative infinity. Similarly, if we're going to the left, left is a negative infinity idea. And then where is my graph going? Is my graph going up or is my graph going down? Again, up is positive infinity, down is negative infinity. So this limit notation is talking about x values and y values at the same time. As my graph is going to the left, where is my y values going? Up or down? As my graph is going to the right, where is my graph going? Up or down? So let's take a look at this from a graph perspective. And then we're going to get to talk about this a little bit more in the next lesson, what the leading term tells you about the end behavior. So looking at this graphically, we are looking to the left Is my graph going up or down? Well, it seems like my arrow is going this way. So as my graph goes to the left, my graph is also going down. Down is a negative infinity idea. So we would say that the limit as x approaches negative infinity of this function is equal to negative infinity. Now we're looking at the right. As my graph goes to the right, what is my graph doing? Well, this looks like it's going down to me. So again, this says as the limit as x approaches positive infinity, meaning going to the right, of f of x is equal to, okay, are we going up or down? We're going down. So that means that this is equal to negative infinity. Let's try this one more time. Let's look to the left. As this graph goes to the left, where are we going? Looks like our graph is going up. So the limit as x approaches negative infinity of f of x, where is this graph going? Up or down? We said up. Up is a positive infinity idea. As my graph is going to the right, where's my graph going? It looks like my graph is going down. So the limit as x approaches infinity of f of x is equal to, we're going down. Down is a negative infinity idea. If you need to pause and rewatch example number 3 and 4 again to reiterate this limit notation, please do. This is a very important notation that will be reiterated through Algebra 2 and Precalculus and Calculus. We will get more practice on this